Okay, here's video lesson 1.4. For calculus, we're going to talk about piecewise functions. Really, really important concept in calculus. So piecewise function is nothing more than a function that is defined by two or more pieces. That's it. It's a function that's defined by two or more pieces. So let me walk you through an example of what a piecewise defined function is, and I want us to consider a couple of things. First, we got to know how to read this statement. Okay, so this is the function f of x. It's equal to x plus 2 if my x's are less than 1, or it's equal to x minus 1 squared if my x's are greater than or equal to 1. So one thing that you can think about is that this part right here on the right hand side is acting like a fence. Okay, and what I mean by that is if I'm on the left side of the fence, because this is the less than sign, so this is the left side of the fence, and this is the right side of the fence. Now it doesn't always have to be that way. If this is greater than 1, this would be the right side of the fence. If this was less than or equal to 1, this would be the left side of the fence. So just looking at the inequality will tell me which side of the fence I'm on. Now how this translates to a graph is, let's go to where x is equal to a 1. So that's this location on the graph. And what I'm going to do is I'm going to make like a makeshift little fence, invisible fence for myself to think about. So I have the right side of the fence and I have the left side of the fence. Okay? So if I'm on the left side of the fence, I'm going to be drawing a line. And that line is going to be the function f of x equals x plus 2. So we now know that the slope of that line is 1 and the y-intercept is up at 2. So I'm going to go to 2, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then when I get to here, okay, since I'm on the fence and it says strictly less than, I'm going to use an open dot. So I do not include that part. So I'm drawing everything to the left of the fence is going to be a line. This is my line to the left of my fence. To the right of my fence, this is a parabola. I'll do this one in green for you because this is to the right of the fence. Okay, well, here's my fence, x minus 1. So this is going to be a parabola where that has been shifted over to the right 1 unit. And at 1, I now can put a closed dot and go ahead and draw my parabola over 1 up 1, over 2 up 4. And I would have this image here like this, okay? So I don't have to have the fence as part of the graph. It's kind of just a way for you guys to see it. Now you can see that this is a piecewise defined function because it's drawn into separate pieces. Now of course we can talk about the domain and the range because we always need to talk about the domain and the range. So the domain of this thing, all my x values, well, every single x value on the x-axis is lit up. So the domain is all real numbers, okay? And in this case, the range is also all real numbers because every point on the y-axis can be mapped back to the y-axis, so I'm good to go. So the domain and range will be all real numbers here for this guy. That's basically what a piecewise defined function is. This is what we're going to be talking about for this little... Okay, here's box 2. We're going to talk about another example, and I'm going to show you a piecewise defined function and how to graph it. So again, my function f of x, I'll do it in yellow for you. My function f of x is either 1 over x minus 4 if x is less than or equal to 4, or my function is equal to just negative 4 if my x's are greater than 4. So again, this is acting like the fence. Okay, so I'm going to go ahead and draw that fence at x equals 4. So here's x equals 4. I'm just going to give myself like a little boundary line here. And there is my fence. This is saying the left side of the fence. And this is saying the right. Okay. So on the left-hand side of the fence, I'm going to draw this rational function. And then on the right side of the fence, I'm just going to have basically a horizontal line at negative 4. Okay. So actually, I'm going to make this positive 4. It's more interesting. So here we go. I'm going to draw on the left side of the fence in yellow for you this rational function. Now you may remember that rational functions 1 over x make the Hurley graph, right? So that one and that one. It's just been moved over 4 units to the right. So I'm going to have this point on the graph, and then the graph is going to have a horizontal asymptote because we've already studied rational functions. So the graph is going to look something like this and then shoot down to infinity there. And this is equal to positive 4 if I'm up here. So, but because it's just strictly greater than, it's going to be an open circle and then shooting off to the right. Okay? So we need to talk about the domain and the range here. So the domain of this guy is all real numbers, x, such that x does not equal the number 4, because clearly right here there's a vertical asymptote, and this point is not a member of the domain because it says greater than. So my domain for the whole thing is that, and my range for the whole thing is going to be, let's see here, I can see that this function maps back to the y-axis all the way down, and then the point 4. So it's kind of a funky range. It would be, if I wrote it in interval notation, parentheses, negative infinity all the way up to 0, and then a union with 4. And that's kind of an interesting range, but that's what it would be. Okay, that's box number 2. Okay, last box is you try to sketch this in your notes. See if you can get the right answer. The square root of x minus 1 if x is bigger than 1, bigger than or equal to 1, and x squared if x is less than 1. Okay, hopefully you got the right answer and your sketch looks something like this. So my fence boundary is over here at 1. So at once I have my fence boundary. To the right of my fence, I have a square root function, which is in red for you, highlighted. And notice that the red dot down there is colored in because it says greater than or equal to 1. On the left side of the fence, I just have a regular old parabola, and notice that that point is open circle because it strictly says less than 1. So hopefully you got something that looks like this, and we'll practice more in class.